Okay, so yeah, welcome back. We want to look at our next question, which says that at the same instant, two boys, Akwasi and Kwabena, who are standing 24 meters apart, 24 meters apart, this one, and begin to cycle directly towards each other. Akwasi start from rest, take note. So let's say Akwasi, this is Akwasi's information. So I'm writing them here. So Akwasi, so we know that Akwasi start from rest. So since he start from rest, then we can say that his initial velocity is equals to 0. Okay, and then they are saying that riding with a constant acceleration of 2 meters per second squared, and his acceleration is equals to 2 meters per second squared and then Kwabena rides with a constant speed of 2, so take note, constant what? Speed. So that's Kwabena. So Kwabena rides with a constant speed. Okay, and then his speed is constant, so it means his initial velocity equals to 2, and his final velocity is equals to 2 because he's riding with a constant velocity. Now they are saying that we should find how long it takes before they meet. But what do we know? We do know that the distance between Akwasi and Kwabena is 24. So this is 24 meters. We don't know how far each of them travel before they meet. So we can go for the distance formulas and try to see how far we can go with this question. So if we are looking for the distance traveled by Akwasi, so we can say that let x be the distance traveled by Akwasi. So this will imply that the distance traveled by Kwabena is equals to 24 minus x, because if the total distance is 24 and somebody traveled x distance, then the other person might have also traveled the remaining distance before they meet. Are we getting this scenario? Good. So now let's go for Akwasi. Akwasi's initial velocity is 0. We don't know his final velocity, so we can go for this formula. So I'm going to pick this formula, s equal to ut plus half at squared, this one. So for Akwasi, we will have, so Akwasi's distance is x, so we have x to be equals to his initial velocity is 0 times the time plus half times his acceleration is 2, and the time we don't know, t squared, and so we have x to be equals to t squared, t squared, x to be equals to t squared. So we can call this equation 1, and then let's go for Kwabena. As for Kwabena, his distance is 24 minus x. 24 minus x equals to ut. His initial velocity is actually 2 because his velocity was constant throughout the distance. So his initial is 2. So putting it inside this formula, that will be 2 times t plus half. His acceleration, does it have acceleration? Okay, so let's see, riding with a constant velocity of this. So what will be his acceleration? Well, they said his speed was constant. You see, his speed was constant. Since the speed is constant, it means the acceleration is 0. Because let's assume that we have v equals to u plus at. Let's assume we don't know what t is, but if u and v are all the same, then that will mean that have v minus v, which is equals to at, and so we'll have 0 equals to at here. So dividing here by t, dividing here by t, we have t. So we have our a to be equals to 0. So whenever speed is constant, acceleration is 0. So it means putting 0 inside the formula, we have 0 times the t squared. So this term goes to 0. So we have 24 minus x equals to 2t. So we can call this equation 2. So we can actually solve these two equations simultaneously. And so putting the two equations together will imply that we put, in place of the x, we put t there. So that will mean that, so we have 24 minus x equals to 2t. This is actually equation 2. So putting the two equations together, we'll have 24 minus t squared equals to 2t. And so rearranging this particular thing, we'll have t squared and plus 2t minus 24 equals to 0. So this is a quadratic equation for which we have to solve. And if you solve this, you are going to get t to be equals to 4 seconds or t to be equals to -6. But time cannot be -6, so this one is obviously not valid. So therefore we can say that it took 4 seconds before Akwesi and Kwabena met. 4 seconds. Take note. So that is how, these are just small application questions. So you go over, if you don't understand, watch it again, and then you see how obviously you do your small analysis and you get your answers. Thank you for watching. Kindly subscribe.